Well, hello and welcome back to math class. Today you're going to notice we're moving on to lesson 6.2, which is solving equations using addition or subtraction. So we're going to kind of move on from what we did for lesson 6.1. Lesson 6.1, we were writing equations. We would read the phrase and we would put our equal sign and our variable. So today, the key idea is equations may be true for some values and false for others. A solution of an equation is a value that makes the equation true. So take your highlighter, your pencil, and I want you to kind of underline that and circle this word solution because that's kind of an important word we need to know. The solution is what makes this equation true. So let me give you an example. If you move down here to example 1, the directions say tell whether the given value is a solution of the equation. So remember, a solution is what makes the equation true. So here's our equation. We'll underline it so we can find it. P plus 10 equals 38. Then we're given a solution that says P equals 18. Well, we have to prove to see whether or not that's true. So obviously we take the 18, we substitute it in, and we say 18 plus 10 equals 38. We took the P out. 18 plus 10. Let's see. 18 plus 10 is 28. 20. Obviously, this is not true. So we would say it's not equal to, and we would say that P is not a solution. All right, so I would go ahead and write over here, P equals 18 is not a solution. This did not work. All right, we're going to look over here. I kind of worked a little ahead, so let's peek and see what I have over here. Here's my equation. 4y equals 56. Y equals 14. We're going to substitute 14 in for y. This means multiply. So we're going to write 4 times, substitute y in for 14 equals 56. Well, over here, you're going to notice I did 14 times 4, and I got the answer 56. So on our paper, we will write 56 equals 56. Obviously, this is true. So we could say that y equals 14. This right here is a solution. Remember, the word solution means a value that makes our sentence true. This one was true. This one was not true. All right, let's move on here and do some try-its. What I would like for you to do is I'd like for you to go ahead and pause your video, and I would like for you to substitute 9 in for A, 3 in for G, 5 in for N, and 14 in for Q. I'd like you to try and solve these equations and see if these values are solutions. So go ahead and pause your video, please. All right, let's see how you did. So you would have substituted the 9 in here for the A. 9 plus 16 equals 17. What is 9 plus 16? 9 plus 16 is 15. I would say that 15 does not equal 17. So this would not a solution. Let's try here. G. Put 3 in for it. 9 minus 3. 9 minus 3 is 6. 6 does not equal 5. Not a solution. Okay, we're going to substitute 5 in. 35 equals 7. Substitute the 5 in for the N. 35 equals 7 times. This one is equal. So we're going to write solution. And look at number 4, Q. You should have put 14 in for Q. 14 divided by 2 is 7. 7 does not equal 28. Not a solution. All right, so we kind of have learned what the word solution means. Solution means whatever we were given for the variable, g equals 3, a equals 9, that value works. That is considered a solution. We were able to solve the problem. All right, so we're going to move on to actually solving some simple equations. I know that you're going to be able to do a lot of this in your head, but I want us to make sure we actually show the work and how to solve them on paper. We're going to use something called inverse operations. Inverse, so go ahead and underline the word inverse operations so you know what that is. And it says here, inverse operations undo each addition and subtraction are inverse operations. So we're going to undo them. We know that these two are inverse, basically meaning they're opposite operations. So we have here the addition property of equality. We're going to write the definition right here, and it's when you add the same number to each side of an equation. And then when we do that, the two sides remain equal. So the addition property is when we add the same number to each side of an equation, the two sides remain equal. And I'm going to show you exactly what that means here in a minute. Well, the subtraction property is going to be exactly the same definition, except for instead of writing that we're adding, we're going to be subtracting. So we're going to say when you subtract the same number to each side of an equation, the two sides remain equal. And if you need to pause the video so you can write this down, you sure can do that. All right, the important thing about these properties is that we're going to do it, if you're listening here, to each side. So if we go down here to example 2, we're going to use addition here. Here's my equation, x minus 2 equals 6. I already know the answer equals 8. Okay, that's not what I want. I want you to show me how we're going to do the inverse operation. So what I like to do is I like to find my equal sign. That would be considered my balance, and I circle it. So whatever's on this side of the equal sign has to equal this side. This is a minus 2. What's the opposite of minus? Well, the inverse operation is add. So we're going to put an add 2 underneath it. And we just said here, whatever we do on one side, we have to do on the other side, each side. So on this side of the balance, I have to add 2. And, whoops, on this side, I have to add 2. A negative 2 and a positive 2 will cancel out, leaving the variable x. And 6 plus 2 equals 8. So now I've proven how I got 8. Let's try this one over here. Here's my equation. I find my balance and I circle it. Here's the variable x. It's with a minus 7. I need to get rid of the minus 7, so the variable is by itself. What's the opposite of minus 7? Plus 7. But the rule is whatever I do on this side of the equation, I have to do on each side. So here's my balance. So let's go over here and add 7 over here. We have to do the same thing on both sides. All right, I'm going to draw a line so I can solve my problems. 18 plus 7 equals 25. Negative 7 and positive 7 cancel, leaving x. X equals 25. Well, let's see. If I put 25 up here, is 25 minus, oh, that does work. All right, let's try a couple more here down on the bottom of the page. This time we're going to look at subtractions. And here's some more subtractions, which means we're going to do the inverse operation, which means we're going to do the opposite. So let's find our balance. It's right there. The variable is k. It's not by itself over here. It's got minus 3 with it. The inverse operation, or opposite of minus, is plus. Whatever I do on this side, we have to do on the other side. A negative 3 and a positive 3 cancel out, leaving the variable k. Bring down my balance, which is my equals, and 1 plus 3 is 4. If I put a 4 in here, 4 minus 3 equals 1. Yep, that is correct. All right, let's try this one. Circle the balance. I already know the answer is 14. I don't want that. I want to show the work. I'm going to do the opposite. Opposite of minus is plus. Whatever I do on this side, I have to do on this side. A negative 10 and a positive 10 cancel, leaving the letter n. Bring down my balance, and 4 plus 10 is 14. Oh, I knew that already because I know that 14 minus 10 does equal 4. All right, let's look at this one. Here's my balance. The variable is r. It has a minus 6. The opposite would be plus 6. Whatever I do on this side, I have to come over here and do on this side. 15 plus 6 is 21. Bring down my equal sign. Negative 6 and a positive 6 cancel. And I have r equals 21. Well, if I put 21 in here, let's see if that works. 21 minus 6, that does equal 15. So I've proven that these solutions have an answer of 4, 14, and 21. All right, so on the back side, we're going to do the same thing, but this time we're going to be doing some subtraction. So if you look at the equation, once again, we find the balance. The variable is x. We want to get it by itself. It has a plus 2. The opposite of plus would be minus 2. Whatever I do on this side, I have to do on that side. A positive 2 and a negative 2 cancel each other out, and the variable x is by itself. Bring down my equal sign, and 9 minus 2 is 7. Let's see. Is 7 plus 2 equal to 9? Yes, it is. All right, here we go. Circle the balance. Here's the variable x. Oh, this one's a little different. The plus is with the x. It's not in front of the 11, but this 11 is a positive 11, which means I could put a plus in front of it, but we usually don't do that. If I want to get rid of the 11, the opposite of a positive 11 would be to subtract it. Whatever I do on this side, obviously I have to do on this side. 26 minus 11 is 15. Bring the balance down. 11 minus 11 cancels. And I found out that x equals 15. Now let's make sure. 11 plus 15. Oh, that is 26. This one worked. Okay, let's try these last three. I have my balance. Here's the variable, the opposite of plus, minus 8 here. And whatever I do on this side of the balance, I have to do on the other. 8's cancel. S equals 9. And yes, 9 plus 8 is 17. Circle my balance for number 9. Plus 6, inverse operation would be minus. Whatever I do there, I have to do on the other side. 9 minus 6 is 3. Bring down my balance. Positive 6 and a negative 6 cancel. And I found out that y is 3. 3 plus 6 is 9. Okay, let's circle the balance one more. Oh, this is another one like up here. There's nothing in front of the 13. If there's nothing there, I know that that's a positive 13. So the inverse of a positive 13 would be to subtract it. Whatever I do on this side, I have to come on this side and do it over here. These cancel, leaving m. And 20 minus 13 is 7. Let's check. 13 plus 7, that does equal 20. All right, well, we're going to stop here, and we'll do the examples 4 in class. So you can go ahead and put your notes away.